Hi guys, today we have a new topic for you, and that is selection software for hybrid integrated solutions for fresh air. Why the selection software is so important? First of all, because you cannot select such units based on catalogs. You need a software that calculates summer mode, winter mode, and give you precise calculations. Before we give you a detailed analysis of software and how to make it, we would like to mention the fact that our company, Damvent, was one of the very first in the EU to develop such selection software. This is back in 2009 and 2010, and due to date we have developed 3 offline desktop versions, and now we are working and we are getting close to presenting our online version. When we talk about selection software for hybrid integrated solutions for fresh air, it's very important to know that this is not a selection software for classic air handling units. In this software must be incorporated softwares for coils, for filters, for compressors, for fans, for heat recovery, either plate or rotary. So this is supposed to be a complicated software, but at the same time it's very important to be made that way so the information inside is very accurate and correct, but also it's easy to work with and can make fast and rapid calculations. We will give you an example how you can do a selection with our own software. So we'll go directly to our Maxi 3 series, and just to make a sample calculation, we will take a unit, for example, for 6,000 cubic meters per hour. Before we go to the calculation, it is important to know that two separate modes should be presented: winter mode and summer mode. So before we start, it is very important to notify this fact. In our selection software, as a preset values, we always put in winter mode minus 15 degrees ambient temperature, just to show, which is very important, that this solution does not use any other additional heating sources in winter mode. So we always put minus 15 as ambient temperature. As an extract temperature from the room, we always put 22 degrees. We believe that below 22 the temperature is not that comfortable, so we always rely on 22. I will change it here to 30%, and now we can perform one calculation. First of all, look at how fast it goes. Now we already have the output data. So on your left side, it is very important that we provide our output data before you go to the detailed preview. Why you need that? Just to make sure that this unit fits to your needs. So first of all, we provide the recovered heating capacity. Then we provide the heating capacity from the condenser. Then we have the total heating capacity. After that we have system power input, but this is a total value for a unit, which means including compressors and fans. And then we provide the correct value for the system COP. Below that you can find the SFP factor for the unit, and last but not least, on our opinion, the most important parameter for every solution for fresh air. This is the supply air temperature. Here is the moment to focus your attention on the fact: please make sure that your supply temperature in winter mode is always higher, equal or higher than the extract temperature from the room. This is very important, because if it's not, if it's lower, it means that this unit or this built-in heat pump is not well sized and designed. Then we go to the preview, and we will pay attention on just several facts and figures, it is very important the rotary heat exchanger, because in our selection software and in all our units we use only sorption type, which means that we have humidity recovery in both winter and summer mode, and normally we provide the dry efficiency, but also the humidity efficiency of the rotary wheel. And the humidity efficiency, if it's a sorption wheel, you will notice that it's always some percentages higher than the dry temperature efficiency. So this means this is a sorption type. On the heat pump side, it is very important that your software or the printout of your software shows several data. These are the inlet temperature and relative humidity, the outlet temperature and relative humidity, but also it's very important to show you the capacity of this coil. The same goes for, in this section, you need to have full data for both the evaporator and condenser. So for the condenser, we have the same data, inlet temperature and relative humidity, outlet temperature and relative humidity, and the capacity of the coil. On the refrigerant circuit, we have the quantity of the compressors. We have the power input of each compressor for this specific calculation point. We have the number of circuits. Very important, we have the COP only for the refrigerant circuit. And then we have operating current and full load current, locked rotor current, all the electric data for the compressor. So these are the most important data for the heat pump circuit. Below that, of course, we have data for the fans and for the sound level. So now we are going to make a comparison analyze with other selection softwares from other manufacturers. But before we do that, we would like to tell you that we will make only an analyze and show you the facts and numbers and maybe put some doubts on some numbers, but you will make your own conclusions. So we will start first with manufacturer number one. Very nice design, very good schemes, everything looks very professional. We will put attention for you, for all the manufacturers, specifically on two things: rotary heat exchanger and heat pump circuit, because you will see that there are some differences. So with this one, we go and see, first of all, that this unit uses a preheater as a frost coil to heat up the temperature from ambient -10 to +5 degrees. That is okay, but on our opinion, it means that this heat pump is not sized to cover lower temperatures than +5 degrees. Then we go down, and here you can see that this rotary wheel looks like a sorption type because we have a very good humidity efficiency. So everything here is okay. Then we go to the data for the heat pump. Up here, so here what we would like to put your attention on is the coefficient of performance, COP, given 18.6. On our opinion, this value is highly exaggerated, because we believe that within this coefficient of performance calculations are not included the energy consumption of the fans. Here it's included only the useful capacity from the heat recovery, from the heat pump, but only the energy consumption of the compressor and the fans are not included. And as the company who first put on the map this specific coefficient COP system or COP net, we feel obliged to show you that. We go to the next one, and here also everything looks very good, well designed, very professional. We go straight to the rotary wheel, and here you can see that the humidity, the temperature efficiency of this wheel in winter mode is 17.7, which is a quite good efficiency, but the efficiency, the humidity efficiency is only 33%, which means that this, and in the summertime, the humidity efficiency, it's written 0%, which means that this rotary wheel is definitely not absorption type. It is only probably condensation type or maybe a hygroscopic type. Just for your information, in our selection software and all our units, they use only sorption type wheels where we can recover humidity in both winter and summer mode. Then we go to the heat pump side, and what is important to mention here. First of all, in winter mode, the evaporator inlet temperature is minus 6.3 degrees. At the same time, it is written the refrigerant temperature, or maybe they mean evaporation temperature, is minus 10.4 degrees with coil phase velocity of 2.6 meters per second, which on our opinion is quite high. We believe that this figure here, evaporation temperature, should be much lower, and in our opinion should be even lower than minus 15 degrees. And this will affect the whole performance of the refrigerant circuit in winter mode, so this will affect also the data for the condenser as well. So this 24 degrees supply temperature might not be 24, they should be lower. Then we go again for COP total, compressor system plus rotary heat exchanger. Again, this number here, 16.9, on our opinion, does not include the energy consumption. The next one, the next manufacturer. So again, very nice and good design, good schemes. We go directly to the rotary heat exchanger. Just to show you its efficiency. So the dry efficiency is 70.6%. But we don't see actually the we don't see the humidity efficiency. Or yes, here it is, exhaust air humidity 37.2, and the material, it's written enthalpy hybrid, which means again this rotary heat exchanger is not sorption type, so maybe it will transfer some humidity during the winter time, some humidity, but not in the summertime. Then we go to the heat pump circuit, and here what we would like to show you is the following. Again, on the extract side, the evaporator inlet temperature is minus 4.1 degree, the outlet temperature in minus 11.5, and it is written that the refrigerant temperature, or maybe they mean evaporation temperature, is minus 15, which again, for a coil with velocity of 2.9 meters per second, that here we put very serious doubt about that number minus 15, and we think this temperature should be much lower than that, and again will affect the calculations for both the evaporator and the condenser in winter mode. If we go to the summer mode, in the summer mode we have, in the summer mode here again we have inlet temperature in the condenser 30 degrees, outlet temperature almost 38 degrees, and the refrigerant temperature is written 38 degrees, which again at this phase velocity of 2.9, it is very unusual. Here we expect condensing temperature, refrigerant temperature even higher than 55 degrees, again which will affect the whole calculations for the refrigerant circuit in cooling mode. So all the rest is it looks okay. Just for your information, for all our units, their maximum speed, maximum phase coil velocity at maximum airflow does not exceed 2.2 meters per second. And usually we calculate our units with average equal or below 2 meters per second, and as you can see through all these calculations so far, the velocity is even above 2.5, which is a very high for a heat pump. Then we go for another manufacturer, just to show you again. We start with the rotary wheel, and the temperature efficiency looks very good, quite fine, but the humidity efficiency again is lower, which means that this rotary wheel probably is not a sorption type. And for the heat pump we have nearly the same doubts here. Again, in the winter mode, the evaporation temperature is given minus 15 degrees, while the outlet air temperature is minus 11.3, and with a phase velocity to the coil of 2.5, again we put very serious doubts in this evaporation temperature and believe with outlet air temperature of minus 11 degrees, this one should be even close to minus 20, which again will affect the calculations, all the calculations and data for winter mode. The same goes for summer mode, where we see that the condensation temperature is close to 45 degrees. In the same time, the inlet temperature in the condenser in summer mode is 25.2, and the outlet temperature is 38.5 degrees, and with this velocity of 2.6, we believe that the condensation temperature again will be equal or even higher than 55 degrees, which once again we repeat will affect all the calculations in summer mode, and probably the data will be different. So once again we showed you how a selection software is made with our DV Select, and then we showed you printouts from several producers to and put some doubts on some numbers. So once again, we try to make an analysis for you and show you the facts so you can make the conclusions by yourself.